question 2, and question 2 says, draw the graph of tan h of x and state 3 of its properties. Then B says, evaluate tan inverse of 0.212 without using the log method. Okay, so the log method is actually the formula. They don't want you to just write the formula and start solving. They want you to work it down from the very first principle. Okay, so let's kick start from number A. The graph of tan x goes this way. We have formed the graph of tan x. We have the y-axis here. We have the negative y-axis here. We have the positive y-axis here. We have the x-axis here. And that's the negative x-axis, and we have the origin. Okay, so let's have our margin. This is our margin. And then we have our margin here. We have our margin. So now, the curve comes like this. The curve comes this way. Okay. Then comes inside through the middle, through the origin, coming out here, and then continue like this. So that's you trace this guy here. Of course, the value here is +1, and of course, trace this guy here. The value here is -1. We have -1 here. We have -1 here. Okay? So, and then of course, the formula for tan h of x is equal to exponential x minus exponential minus x over exponential x plus exponential minus x. So this is what we just draw now, the graph of tan x from -1 to +1, and that is the typical graph of tan x, and the characteristics. Say at least 3 characteristics, 3 properties. The properties of tan h of x. Okay, the properties of tan h of x is equal to, number 1 says that tan h of 0 is equal to 1. Then secondly, the values of tan h of x ranges from -1 to +1. As you can see from the graph, we have the limit from -1 to -1 to +1. That's the range of values of the hyperbolic function tan h of x. Okay? So we have number 3. The curve is symmetrical about the origin. The curve is symmetrical about the origin. It takes 6 turning paths through the origin. So it says symmetrical about the origin. That shows that it is an odd function. Every odd function takes its symmetrical path about the origin. Every odd function, to every odd function, the curve must be symmetrical about the origin. And then to represent the odd function of tan h of x mathematically, we have the tan h of -x is equal to minus tan h of x. This shows that the tan h of x as an hyperbolic function is an odd function. Okay, so I've completed 3, but let's add 1. As x tends to negative infinity, comma, then h of x tends to negative 1, and as x tends to positive infinity, comma, then h of x tends to positive 1. Okay, so this tells you that the value of tan of any number, no matter how big it becomes, it ends in 1, positive 1. That is if the higher number is in positive side, then if the higher number is in negative side, no matter how big the number becomes, the value of tan of that particular number ends in negative 1. Okay, so the next question is number B. The B part of the question, we have evaluate. To evaluate, okay, we have a question there already. So we have the B part of the question. We are looking for tan h inverse of 0.212. Okay. So now we're going to call this whole function x, because there is no variable here at all. So we're going to let the whole question to be equal to what? X. So my solution goes this way: x equal to tan h inverse of 0.212. Alright, so when we take tan h inverse to cross to this side, is going to give us normal tan h of what? X, equal to the number here, 0.212. Okay, so what is going to happen now is we're going to write or recall the formula for tan h of x. We check the diagram we just drew in number 1 example. You find out that the formula for tan h of x is exponential x minus exponential minus x all over exponential x plus exponential minus x equal to 0.212. Okay, so now we cross multiply. This is number 1. We cross multiply. We are going to have exponential x minus exponential minus x. That's everything here multiplied by 1 will give you this equal to. Then everything here multiplied by 0.2. 0.2 multiplied by this will give us 0.212 exponential x. So 0.212 is going to multiply both this and this. Then 0.212 multiply the second, we have plus 0.212 exponential minus x. Okay? So now we're going to collect items. The one having a positive power of x will go one side and we'll select them. Then the one having a negative power of x should go to the right hand side. Okay, we have exponential x, then the positive power of x is this. So we'll take this guy that has the positive power of x, just the same thing as this. So minus, okay, 0.212 exponential x to cross to this side will give us negative 0.212 exponential x. So this guy is having a negative power of x. You will take it to this side to join this guy that has the same negative power of x. So negative exponential minus x cross to this side will give us positive exponential minus x, which will now join this guy plus 0.212 exponential negative x. So you can see what's common here is exponential x. We have exponential x into, of course, we have exponential x into itself is 1 minus 0.212 equal to what's common here also is exponential minus x. We have exponential minus x into Exponential minus x into itself is 1. And then exponential minus x into this to cancel out, we have 0.212. Alright? So we're going to add this guy together. We're going to subtract 1 minus 0.212. We're going to have 1 minus 0.212 will give us 0. We have exponential x into 0.788 equal to exponential this 1 over exponential x according to indices. 1 plus that is 1.212. Alright? So for us to work on this now, we're going to exponential x to multiply this exponential x. That's all. Exponential x cross multiply, kind of cross multiply. So exponential x multiplied by this, we're going to have exponential x all squared times the number here is 0.788 equal to what's remaining here is 1.212. Then making exponential x all squared to be the only term lying on the left hand side, we have exponential x all squared to be equal to this. Will divide this. We have 1.212 divided by 0.788. So taking this one down, like dividing both sides by this, we have this. Okay, so 1.212 divided by 0.788. Of course, will give us exponential x all squared is equal to 1.5381. So that exponential x will be equal to plus or minus. Of course, we might just take the positive value. We have the square root of 1.5381. So that exponential x becomes equal to the square root of that will give us 1.2402. So that x now will be equal to, removing this e, we have to introduce ln. That's ln of both sides will make x to be equal to the ln of 1.2402. So the final answer will give us, of course, you punch the ln in your calculator, you can see the ln there. Let me show you guys. We have the ln here. Okay, we have the ln of 1.2402. Of course, you see the answer. We have 0.2153 to 4 decimal places. So this value actually is the answer to tan H inverse of 0.212. Thank you and subscribe for more. Let's get to the next question.